So let me ask you a question. What if our strongest, most advanced materials weren't mined from the Earth, but grown from it? Today, we're going to dive into Hempoxies, a radical new class of materials designed to kickstart what's being called a post-predatory future. It's all about moving us away from petrochemicals and into a whole new era of green engineering.
In this quote from the system's creator, Marie-Soleil Sachat-Landry, really just frames our discussion perfectly. You see, this isn't just about making another bioplastic. No, this is about completely reimagining material science from the ground up.
Okay, let's really get into this. For what? Over a century now, our entire world has been built with materials that come from fossil fuels. It's a model that is, when you think about it, fundamentally predatory. It relies on finite resources, and it creates this persistent, toxic waste. We've kind of reached a dead end.
Yeah, this slide just illustrates the two competing futures perfectly. On the left, you've got that familiar story, take, make, waste. But look at the right. That's the Hempoxies model. It's a truly circular system. We're talking about materials that are grown, used to make things like, say, car parts or electronics, and then can be fully recycled. And they could potentially be sequestering carbon at every single step. It's a huge shift from extraction to regeneration.
So the big question is, how do we make this shift from just a cool theory into an actual reality? Well, the answer lies in this really elegant and exhaustive technical blueprint, the Hempoxies 9-component formulation. Let's break it down.
So here it is, the entire ecosystem all on one slide. And this just brilliantly illustrates the core principle. Every single component, from the polymer matrix that kind of holds it all together to the super strong reinforcements, it's all derived from a single crop, industrial hemp. It's a completely vertically integrated system.
All right, let's get into the first major innovation and see how this all builds up. The smart polymer matrix. Now, this isn't just some simple bioresin. It's a dynamic network that's designed to solve one of the biggest problems in modern materials.
And you know, that really leads to the crucial question, because traditionally, you get one or the other, right? You get strong thermoset plastics that are permanent and totally unrecyclable, or you get weaker thermoplastics that you can melt down, but they just don't have the same structural integrity. So how on earth does Hempoxies achieve both?
The answer is a really special class of polymer called vitrimers. And the source material uses this fantastic analogy. Think of them like special Lego bricks, okay? They're really strongly connected, which gives them the strength of a permanent structure. But when you apply heat, the bonds soften just enough to let those bricks kinda swap places. This allows the material to be reshaped, repaired, or even fully recycled without just falling apart.
So what's the secret ingredient that makes this whole vitrimer chemistry possible? It's a genius molecule, and it's derived from hemp lignin, called QFMHL. I want you to think of it as a chemical multi-tool. It single-handedly hardens the resin, it enables the recycling, it adds nanoscale strength, and it protects the material from breaking down. We're talking 4 jobs, one elegant molecule.
And for any chemists and investors watching, the process here is just as revolutionary. The creators developed something called a one-pot synthesis. This brilliant shortcut avoids a really common chemical dead end known as the Ahmed trap, which is where reactions can get stuck and just fail. Bypassing that means production is way more efficient and less wasteful, and that's an absolutely critical step for commercial viability.
Now, if that smart matrix is the brain of the system, this next part, well, this is the skeleton. We're actually moving from chemistry into high-pressure physics to create a reinforcement material that honestly sounds like something straight out of science fiction. I want you to meet hemp-derived diamond nanothreads, or HDDNS. The source material calls these the technological crown jewel of the entire system, and for a really good reason. These are one-dimensional threads of carbon, but unlike, say, nanotubes, their internal structure is pure diamond.
And to create something this exotic, you literally have to replicate the conditions you'd find deep inside a planet. These nanothreads are forged under these immense pressures of
20 gigapascals. Now, to put that in perspective, that's about 200,000 times the pressure of the atmosphere around us, right now. It's just an immense, crushing force, and it's what's required to forge these perfect diamond bonds atom by atom.
So what happens when you subject carbon to that kind of pressure? Well, the result is a material with almost unbelievable properties. We're talking about a stiffness, a resistance to bending, of over 850 gigapascals. For comparison, high-strength steel is somewhere around 200. So this isn't just strong, this is a material that could outperform the most advanced composites used in jets and spacecraft today.
And this slide really puts that strength into context. Carbon nanotubes, which are themselves a legendary wonder material, they top out around 70 GPa in tensile strength. These diamond nanothreads are estimated to reach 134 GPa. That's nearly double the strength. This isn't just an improvement, it is a game-changing leap in performance.
Okay, so that is some truly incredible science. But, groundbreaking ideas can stay locked in the laboratory forever. So what's the strategic plan to turn Hempoxies from a research paper into a full-blown industrial revolution?
Well, this timeline gives us a really clear roadmap. We're currently at what's called Technology Readiness Level 3, which means the science is proven at the lab scale. The next critical steps are empirical validation and then pilot scale-up, with that long-term vision of displacing petrochemicals and really enabling that organic revolution. And this isn't just wishful thinking. The source material lays out a very clear, 6-point action plan. This is the playbook. From scaling up the high-pressure synthesis of the nanothreads to building strategic partnerships and educating the market, this is a credible and comprehensive strategy for any investor to see.
So why does all this matter? Well, because the market is ready. The global biocomposite market is projected to nearly triple in size this decade. This is not a niche opportunity, it's a massive, accelerating shift in global industry. And Hempoxies are positioned not just to participate, but to lead by offering performance that other biomaterials just can't match.
So when you combine that recyclable Vitromer chemistry with an ultra-efficient synthesis and then reinforce it with diamond nanothreads and do it all from a single renewable crop, you get more than just a new material. You get a blueprint for an entirely new way of making things. So the question it leaves us with is a big one. Are we witnessing the end of the petrochemical age and the dawn of a new organic one?